Ethernet has come a long way, but one of the areas it's used is in automotive and in industrial applications. And there's a new standard out, it's been out for a while, T1S. Could you tell us a little bit about that?
Yes, 10BASE-T1S Ethernet is a standard that's used to connect at the edge of Ethernet networks, where the interface between the digital world and the physical world occurs. So it's a 10 megabit per second system, so it's used to connect sensors and actuators and other devices that are going kind of between the computer and the real world, and to connect various kinds of devices to it. So it's an expansion of Ethernet. It's complementary to your more standard OT and IT applications, information technology or operational technology. It allows you to have Ethernet everywhere. So it's very complementary to what already exists in the Ethernet world. It is basically a new physical layer, a new way of connecting devices to a single wire, where all the devices are connected to one wire. You don't need to have switches, so you reduce some of the cost of an implementation. And it allows you to, as I mentioned before, to use Ethernet for everything. You don't have to have specialized communication technologies in all these devices that then need to go through a gateway before the data from those devices can be accessed by the rest of the IT infrastructure that you might have in an organization.
Now, are there any particular standards in terms of the wiring, the connectivity, or is that something that is more flexible from a designer standpoint?
The 10BASE-T1S is basically the physical layer. It describes the channel that is used to interconnect things. It uses a single twisted pair of wires instead of like 2 or 4 pairs that is used for more standard Ethernet applications. It's an IEEE standard. As I mentioned, just the physical layer. Above the physical layer, where in the OSI reference model you have layer 0 at the physical, then layer 1, sort of the data connecting to the physical world, and then layer 2 and above. All the infrastructure from layer 2 and above is the same for any Ethernet device, and this just connects into that.
Okay. How about support from the microprocessor end? Do you have this built into any chips directly? Does it require interface chips?
Yes, there are chips that implement this particular physical layer. There are PHY devices, like there are PHY devices to connect to 100BASE-TX. There's a PHY device to connect to 10BASE-T1S. That requires that the microcontroller have a MAC, a media access controller, inside the microcontroller. Those tend to be sort of higher-end microcontrollers that do that. There's another variant of this technology called a controller that has a SPI interface, a serial peripheral interface on it. So you don't need the MAC in the microcontroller. You can use that to connect to simple 8-bit, 16-bit microcontrollers. So everything's built into this controller chip. On one side it talks 10BASE-T1S, on the other side it's just a serial stream. Going forward into the future, there's also what's called the Open Alliance 3-pin interface. That's still more, it's been defined, but there are no devices that implement that yet. That will have a 3-pin interface to connect to an analog transceiver, kind of like CAN. It's done in the CAN world. The CAN world has something inside the microcontroller and then an interface to an external transceiver. That transceiver incorporates all the analog components that you need to connect to a wire. And typically that allows you to take all the digital stuff out of it so that you can go to smaller and smaller geometries and take the advantage, the cost reductions of including all that in a microprocessor. And on the analog side, it allows you to make those chips in more robust technologies that are better at they have more environmental resistance, if you will. They won't be damaged as much by high voltage or electromagnetic interference or the like. It makes up for a more robust connection to once you get out of whatever your device is that has the chips inside of it.
Now, would this interface support some of the real-time Ethernet standards that are available?
Yes, yes. You can run AVB, TSN, all those types of standards right over it because it's just Ethernet. It's just another variety of Ethernet. The other thing that Microchip has that's very helpful is what's called an endpoint. That's a chip that has the Ethernet interface, plus it includes an AVB stack inside of it. So the designers don't have to go figure out what TSN and what AVB is. It's all built into the chip. It's basically a dedicated microcontroller with an Ethernet interface that has the software stack. The issue with TSN is that it's really a connection of standards, and not everybody implements all those standards. There's 5 or 6 different standards and then it's up to the designer to figure out what standards are involved and then how to implement them. Whereas with an endpoint, all that's already implemented inside the endpoint chip. And that endpoint chip can connect to 10BASE-T1S, or it can connect to other speed grades of Ethernet.
You have a number of demonstrations that employ this. Could you tell us about them?
Well, in this demo, we are showing 10BASE-T1S Ethernet technology. It's a single twisted pair of wires that's going to all these LED boards. There's 4 boards connected to each node. What you can see here is a fluid motion of the image, so everything is synchronized together. It's just showing some images, but basically 10BASE-T1S is the interface between the digital world and the real world. The purpose here is to show time synchronization, to show the multi-drop capabilities, because it's a single wire that doesn't require switches, Ethernet switches and the like. All the devices are connected to the one wire. There's 19,200 LEDs here being driven through 10BASE-T1S, and this just shows different images. If I change the mode, I can show different types of graphics going on, or I can turn it on into a camera mode, where you can see me. There's a camera up there, and you can see that as I move my hand, there's really no delay between the movement of my hand and what shows up on the screen. So it's all synchronized. This one is not actually running a TSN stack, but it could be running time-sensitive networking for any kind of application that requires that. This is another demonstration of 10BASE-T1S technology connecting different nodes together. But in this case, we're also highlighting the security aspects of Ethernet, where we have a board that's basically implementing an air conditioning system in a vehicle. You can set the temperature. As you set the temperature, the fan changes, it speeds up, it slows down. Then there's a board driving these motors, so you can see sensors and actuators in action running over 10BASE-T1S. Now, as it's doing that, there's a board here that's sort of a hacker board. It's listening to the network, and then it starts, when you press a button here, it can start injecting spoof messages, and then the network goes a little bit crazy. When the attack happens, the motors start turning, the LED here in the fan starts going crazy. Then you turn on MACsec, which is an Ethernet security protocol that requires all the devices and the messages to be authenticated. Once it does that, you can see on the screen here that the spoof messages are still being injected, but they're not being connected to, they're not being listened to. So the network remains stable in spite of having an attack being done on the network. That highlights how, because this is Ethernet, there are many security mechanisms available for Ethernet. You can run them right and secure this type of network also against any kind of intrusion. You can encrypt the data so you can't see what the messages are that are flowing over it.
Well, great. Thanks for filling us in T1S. It's a great platform, and one I think is going to be very interesting for Microchip products.